If we pretend that this is a swimming pool that holds 65,000 gallons of water, then we have to, and we know how many quarts of blood your heart pumps, but we had to figure out how many weeks it would take for your heart to pump the 65,000 gallons of water. You would use a unit conversion, converting from gallons to quarts, and then converting time from seconds to weeks. So this is how we set it up. For this problem, we had to figure out where the letters went on these three diagrams that folded up into a cube. So we made the letter given blue, which was A, and then we folded it up and figured out where the rest of the letters went, so it's spelled math. So we figured out the letters in black pen, like that, and then we would just fold it back up to check if they were in the right place. And this was using physical representations and diagrams, because otherwise it'd be really hard to figure it out in a two-dimensional way. Alright, if we pretend that this cup of water is a boat traveling 15 miles a day, but you get pushed back every night 3 miles, and you have to travel 85 miles, but you don't know how long it's going to take you, well, you can make a systematic list, and you would make 3 columns, one with the day, one with the number of miles you would travel if you didn't get pushed back every night, and then the miles you've traveled in total since you started until you got to 85, at least 85. So this is our list, and we found that you would get there on Tuesday at 93 miles. Okay, for this problem we had to figure out in an algebraic way how the two accounts would differ after 13 weeks, and we set up 2 equations, and here they are. Y represents the amount of money they had in their account, and X represents the number of weeks that have gone by. So to figure out how much money they have after 13 weeks, we substituted the number of weeks for X, and we got these 2 numbers. So Eva had 305 and Teresa had 356, and then we figured out how which week they would have a $3 difference, and we guessed 11. So we substituted X for 11, and then for Eva we got 335, and for Teresa we got 332. So that's the $3 difference. For this last problem, we had to figure out the total number of vowels in every person's name for the class, which is 33 people, and we used the strategy of solving an easier related problem because we took 10 of the names and figured out, we added them all up and then divided it by 10 because we used 10 names. So we found the average number of vowels in a group of 10 names instead of 33, and the average was 4, so the average for a group of 33 names would still be 4. So that's how we solved an easier problem.